All right, welcome back.
Hey, developers. All right. Did you get your coffee?
Yeah.
Yeah.
We're good.
We're good. We're wired.
Right, so...
But we're also wireless.
Oh, there we go. A seamless link to the next session.
Yes.
You're good.
Yeah,
really good.
I'm trying.
Yeah.
I'm trying.
So this network session is about networking. So
I love
we're going to talk about networking. Yeah. Now, you know, it can be a bit of a dry subject. You're just moving stuff from one place to another. But
it's not dry.
These Windows Phone devices are like so full of different networking capabilities. In fact, the next session after this is about NFC and Bluetooth as well.
Have you seen the network capabilities of this new device here? Is this a iMate? I don't know. HTC. You're going to love this. The networking, it's got a joystick on it.
It's a paperweight.
No, this is great stuff. You wouldn't believe what's on this phone.
Yeah.
I'm excited about networking. I think it's arguably the most important thing.
Well, indeed. There's a lot of stuff to cover, so let's get straight into it.
Yes.
Network, there's a nice network drawing.
Look at that icon.
Isn't that great?
Wow.
So this is what we're going to talk about, networking for Windows Phone. There are a couple of APIs, web client, HTTP web requests, which you use for kind of low-level, raw HTTP requests across the network. We're going to mention briefly sockets, so we haven't got a lot of time to dig into that, unfortunately. But then we're going to spend quite a bit of time on web services and OData, because there's a lot of interesting developments in that area. Simulation dashboard. Now, data compression, very important for making a good quality network connection, just to make sure that you're using compression on the wire. Phones run on crappy networks most of the time. You have to assume that they're going to be. So anything you can do to minimize the amount of data traffic you require, the number of bytes you require to transmit in order to get the data across is a good thing.
Unless you're in Korea.
Really?
They've got a great network everywhere.
Yeah.
Saturated.
Yeah. Now, not included on that list, because I have added it at the last minute and forgot to add it to the agenda, is we're going to have a quick introduction to Azure Mobile Services, which is a new thing that came out. There was good coverage of that at the recent Build conference. So
excellent.
We're going to take a very quick look at how that works, because there's some pretty exciting stuff happening with that as well. Okay, so that's where we're at. Networking on Windows Phone. So first of all, introduction, what we have got in terms of support for networking features. Good support for WCFs, accessing WCF services in all their different flavors. RESTful and SOAP and all the rest of it. HTTP web request and web client are the low-level APIs. Sockets, as I mentioned. We've got full HTTP header access on requests. That's something we didn't have when Windows Phone first came out. We have no restrictions like that. And we have full support for NTLM Kerberos authentication in Windows Phone 8. So there we go. So,
a dream come true.
Yeah.
Realized.
Really. So this is another feature that's adding up to the value add for our enterprise applications. So intranet. We've now got good, strong authentication there. So
Kerberos.
Indeed. So the new features in Windows Phone 8. In summary, what we've now got two different sockets APIs. So system.net, which is what we've been using forever in Windows Phone 7.1, is obviously all still there, but that has been upgraded with new features, notably listener sockets. But we've got the Windows RT API as well. Windows.networking.sockets is in there, so that's an alternative. So if you're doing cross-platform between Windows Phone 8 and Windows 8, you can share a lot of your code there. Support for IP version 6. So a lot of this kind of stuff comes from the benefits of having the shared core with Windows 8.
Right.
Because a lot of the support for things like IPv6 is kind of at the low level of the OS. So these are some of these shared modules that we're taking advantage of at a low level of the OS.
We're happy to ride on the coattails of big Windows.
Yeah, that's right. So that's a good benefit of IPv6.
Let's get all the stuff we can get for free.
Yeah.
Yeah.
And we've got listeners, or NTLM and Kerberos, I mentioned that. We've got incoming listener sockets. So with sockets, before, if you wanted to do a sockets connection from one Windows Phone 7 device to another, you basically couldn't. Right. You had to kind of go via an intermediary, sort of sitting on a server or something. So that sucked.
Right.
Now we've actually got listener sockets, so you can open a socket and wait for an incoming connection.
Feels peer-to-peer-like to me.
Yeah, indeed. Yeah. And we've got WinSock support for C++ dev. So that's been added in. We mentioned this yesterday. It's kind of primarily there. It's not there because we kind of think, oh, you're going to go out and start writing all your stuff using WinSock. But it's there for helping you to port existing code libraries that you may have.
Right.
So this is a quick summary of those networking APIs and a comparison of what we have on the Windows Phone 7, Windows Phone 8, and Windows 8 platforms. So the two main APIs for programming that we've used on Windows Phone 7 are Web Client and HTTP Web Request. Now, Windows 8 has a flavor of HTTP Web Request, but it has been rewritten to just use this async await task-based methods. We don't have those async await task-based methods in Windows Phone 8, but I'm going to show you in a few slides' time how we can work around that, and you can actually use make awaitable calls to using HTTP Web Request. So we've got a kind of a workaround for that. Instead, the web client is the brain-dead easy API to use, and we've still got that on Windows Phone 8.
Which is great for people like me.
Yeah, absolutely.
Brain-dead.
Yeah, but it was too complex for Windows 8 devs, so it got removed from there. And instead, they have a whole new one called HTTP client, which was is in the version of the APIs used on Windows 8, which is totally asynchronous and very efficient. And unfortunately, we don't have that on Windows Phone 8. A couple of other flavors of convenience APIs, if you like, on Windows 8, the syndication client and the AtomPub client are specifically for accessing those kind of feeds. We don't have those. But then when we get down to old school Asimix web services, SOAP-based web services, great support across all the platforms, WCF services and OData services, we've got a good story there.
And remember, when we say WCF services, we really mean things over HTTP. Some people will say, oh, well, you mean you're going to do named pipes or mail slots over the internet?
Right,
Probably not so much.
No, that's right.
Yeah.
No, so yeah, we're still talking basic HTTP web request response stuff.
Absolutely.
Which is, when you're working over the internet through mobile operator networks and that sort of thing, that's really what we need to constrain ourselves to.
Named pipes don't do well through routers.
No, not good. No.
Not so much.
No.
Okay. All right.
So that was a quick summary of the APIs. Now then, this thing about async support, async and await, which is the new way of writing asynchronous code. Yeah, and it's great. It's cool stuff. Kind of, if you're new to it, it does take you a little while to get your head around it. It's a new paradigm. Oh my God, I used that word.
Wow.
It's a new programming approach to doing this kind of stuff. In desktop.NET 4.5 and in the Windows 8.NET for Windows Store apps, all of these networking calls, as long with everything else that is a potentially long-running operation, they're all now based on this new task await, async and await model, the task programming library stuff. And we don't have that, unfortunately, in the Windows Phone 8 APIs. So, but we can actually kind of add this with a few little workarounds, and I'm going to show you that in just a moment. But before we do, let's tackle this one head on.
Right away.
Right away.
We're not going to shy away from tough stuff.
No, that's right. So there is something awaiting to trip you up. Trip you up if you are working with the emulator, and it's a difference from it's quite a substantial difference from the way that the emulator on Windows Phone 7.1 worked. Yep. So we need to look at this. Now, what we've got is the problem is this: in that with Windows Phone 7.x, the emulator was based on the previous virtual PC virtualization technology. And it wasn't actually, a completely separate client. It was actually using shared networking. It was hosted by the development PC OS, and because it had that shared networking, there was this neat little trick they did that you could access resources that you had created on your own dev PC in Visual Studio just by using a local host URI. Now, actually, what local host means is on the same device where you're running the code. So actually that shouldn't have worked. I mean, it was a convenience for developers, so you could just test your stuff out and it would HTTP localhost from your code running on the Windows Phone 7 emulator, and it would hit your service. And it was great because it was very productive. That doesn't work anymore with Windows Phone 8. The reason being that the new emulator is a virtual machine running under Hyper-V. It's using the newer virtualization technology. It virtualizes right down to the hardware. So it is actually a completely separate host, a completely separate computer on your network. So if you try and access a resource from code running on that emulator using localhost, it won't find it, because localhost means the emulator itself, means the Phone 8 device. And you're not running the web service on that Windows Phone 8 device. So instead of using localhost, you need to just use the host name or the raw IP address in your URIs. So that doesn't sound so complicated, does it?
No, how hard could that be?
Indeed. How hard could that be? Well, that's actually from the client side, that's all you have to do. But there is a complication again, because most of us, when you're working on networking stuff, you're going to create a little OData service or something in Visual Studio, and you will then expect to then write your client, you'll add service reference, and you'll run it, and it will fail. And the reason why it will fail is because you've got a lot of configuration you need to do on your Windows 8 box where you're running Visual Studio. So first of all, if you're doing WCF services, you need to ensure that this HTTP activation feature is turned on using in the Turn Windows Features On or Off dialog. So drill down to .NET Framework 4.5 Advanced, go down under there to WCF, and you need to check the HTTP activation there. And then you've got a choice. You're then going to create your website. Now, by default, when you create an OData service, for example, in Visual Studio 2012, that is going to be hosted in IIS Express. So IIS Express is this is a web server that's that's constrained. It means you don't have to. It's not like full IIS installed on the box, so you don't need to have admin privileges to run it. And it's a very convenient way of testing your ASP.NET MVC apps and this sort of thing. So for pure web developers, it's great, and it just gets hosted in IIS Express. It uses the full IIS code, but it's just a dev version of it. So if you create your service, it will be hosted by default on localhost : some port or other, so localhost : 18009. So there's a little window there showing an ASP.NET MVC4 mobile app that you can create in Visual Studio, and it will have that port number, and it will be on localhost. You still won't be able to access that because by default IIS Express does not accept any connections from remote hosts, and your Windows Phone 8 emulator here is a remote host. So this won't work either. So we have to then reconfigure our website, and it's a slightly contorted sequence of things you have to do. First of all,
kind of like Cirque du Soleil on your device, on your laptop.
It is. It's totally like Cirque du Soleil.
Contorted, yeah.
Yeah. So what you have to do is first of all remove your website from your Visual Studio 2012 solution again. Then, if you go into your My Documents folder, there's a subfolder in there called IIS Express, and drill down to config, and then under there you'll find a file called applicationhost.config. And every time you create a website in Visual Studio, it will put a new entry into this file. It's an XML file. There's a section in there that's sites, and you'll find the new site you've just created in there. And that is where it states, you see that binding line there? It will say binding information equals, and then stuff you see there, asterisk, colon, then the port number, whatever it's assigned to you, and then it will say colon localhost. So you need to go in there, edit that, and actually replace localhost with the real name of your PC, and save the changes. And then you go back into Visual Studio and add existing website, so add that website folder back into your solution again. And even that's not quite enough, you're nearly there. So then you've got to run a couple of command line prompts. So you start a command prompt as administrator. First of all, open the port in the firewall using that command there for the port number. Here we're using an example of 18009. And you also need to add a URL ACL. This is a kind of a reservation that allows you to use that port number for remote requests. So you need to do that second command there, the netshare http add URL ACL. And again, instead of your PC, put the real name of your PC and then the whatever port number. Now, finally, you can just test it with the desktop browser, and we're hosted at, and then you can, using the URI of your real PC name, colon, and whatever port. Phew. And then, actually, your code running in the Windows Phone 8 emulator will be able to access it. All good fun.
It is good fun.
Right, so, having told you all of that, we're now going to drill down to the code. So let's do web client first. So this is the simple API, very nice and simple. This is the old school way of doing it, the Windows Phone 7.1 way of using the web client. All you need to do is new one up. Then you hook up an event handler for the download string completed. This is a download string. There's different flavors of different APIs methods on this class. And then at some point in your logic, you'll call the download string async method, passing the URI where the string can be loaded from. And that string could be an XML file, could be some JSON, could be whatever. And when that download is completed, obviously the event handler will fire and you can get at the text. Right, and I said I was going to show you how you can use async await. So web client on Windows 8 has been replaced by HTTP client, which is purely async based. But we can get web clients to, we can add async behavior to it with some custom extension methods, which allows you to, and these extension methods, and I'll show you them in a minute in a demo, allow you to add download string task async methods to that web client. So you can now use the async await pattern to make calls, which is very much nicer. In fact, I'll show you that demo now. All right, so in Visual Studio, if we can show that on the demo machine, there we go. This has got there's actually two projects in this solution. You can get all this code. We're making that available to you. There's the old school one, which does it the old way with the download string completed, but I'm going to run this one, which is the Twitter Reader web client. This is the canonical HTTP example, and let's just run it first, just to show you that it really works, and then I'll just show you the code. So this is a production from Mr. Rob Miles. This is a couple of what we're going to go off and do is find out what he's been tweeting about, and there we go. Actually, and the most recent one is actually the report he tweeted about. He posted up about how he just had his little operation. So,
oh wow!
So he hasn't tweeted since then. So I hope you're feeling well, Rob. You know,
broken-hearted.
Yeah. So.
Get better.
He's sadly missed. So yeah,
Big
get
time.
better. So and then there's his recent tweets. So very, very simple. Obviously, you must have seen a million Twitter readers. But the interesting thing about this sample is just that the code uses the async await. So let's go and find it. Here we go, load button. So there we go. This is the URI to go to Twitter and download the most recent tweets. We're just getting the 10 most recent tweets on there. And here we go await client.download string task async to that. So that will just go off and call us back kind of when it's actually completed and given us the string, and we then parse it using this X element link to XML and post it up on the screen, which is what we saw there. So we're projecting that to a collection of Twitter post objects. These are extensions though, so just use this, get this code and use it in your own one. You need this folder basically, the web client extensions. There's a couple of utility ones. This is the interesting one, web client extensions. This is where we add these extension methods, download string task async. They're extension methods, which means you can use them with the web client class. So use this code and yeah, you've got nice async await with the web client. Right, and next. Now we're going to look at HTTP clients. So if we can go back to the slides on that one. If you want a bit more control, so web client is nice and simple and probably works for most of your HTTP access, but HTTP web request is a bit more complex. It gives you a bit more control. You get right down to the streams. So this is the old way of doing it. You'd new up an HTTP web request. Well, actually, you don't new one up. There's a static method on it called create, which returns you an HTTP web request instance. We can set some HTTP headers, and then you call begin get response, and you have to give it an async callback, a delegate which is going to handle the response when it comes back. And you have to pass, in that begin get response, you must pass the original HTTP web request or a custom object that you've created that includes that HTTP web request instance in it. You need that because you need that to close things off and actually get at the response when the call comes back. And this is what you do in the response. It's all this complicated code. I'm not going to walk through it. You can look at this and use it yourself, and it's well documented. But you can see you get right down to the response stream and pull out the data. And then, of course, you've got a lot of error handling as well, also try-catch stuff around there. So loads and loads of code compared to the web client to kind of actually achieve the same thing. But if web client doesn't work for you, you need a bit more control, then this is the way to go. Now, again, using the TPL pattern, which is the Task Parallel Library, which is the proper name or the originating name for the async await pattern.
Wow.
You start off the same, HTTP web request.create, to give you an HTTP web request instance. Again, we're setting the accept header on that. This is actually going off to an OData service and getting the verbose version of the JSON feed. We're going to look at that a little bit more shortly. And now this is where this isn't an extension method. This is something you can do with any old school begin-end, any API that offers begin something and then end something. So in this case, it's a begin get response and end get response. So you new up a task factory, and that has a method on it called from a sync, where you just give it the begin method and the end method, and you can put an optional state object in there as well. And then you can await that task, and you're making awaitable calls to it. And it wraps up all of the complications that we saw before and makes the code much more concise. So this is definitely the way to go. And then once it comes back in, you're pretty much into the same story as before. So you can get the response stream, but with the benefits that exceptions because we're using the async await pattern, you don't have to marshal things back to your originating thread. The exceptions get thrown on the originating thread. The response comes back on the originating thread, and it's a much better way of coding these things. Error handling, like I said, try catch. You don't have to marshal it back. There's no dispatcher.begin invoke, which actually was needed for the previous example. So I've got a sample here on the demo machine. Which is doing just that. This one is calling out to the Northwind service out on the, it's actually out on the web, it's actually on the services.odata.org, so it's on the odata.org site. It's one of their test services you can use. We're setting the application/JSON semicolon OData equals verbose, and then we're using the TPL pattern to make that call to that. And we're going to get back all of the suppliers that are in the Northwind database. And here's where we're awaiting that. So I'm just going to step through that. We're just going to check what content type we've got back. And yes, it sent us back some application/JSON, so we're looking pretty good here. We can read the response into a stream object, get that data out of it, and then I can just show you what it looks like. This is an OData feed. There are lots of JSON, nicely formatted, very pretty. These are all of the, I'm sure this will be very familiar to many of you, the suppliers in the Northwind database. And then I'm using JSON.net to